Late autumn, 1944. A thin fog hangs over a battered forward airstrip somewhere in France, blurring the edges of the metal planking and the rows of olive drab tents that pass for a maintenance depot. The ground is still trembling from the last P-51 that limped home, its left landing gear twisted, its wing skin torn open like a cracked shell. Mechanics jog toward it across mud and oil-soaked boards, shouting for jacks and stands, but one man stops a few paces short. He has seen this kind of damage too many times. A small-town garage mechanic before the war, he knows what this means: days of measuring, bracing, realigning, remeasuring, and at least one Mustang grounded when every fighter is needed tomorrow. He wipes the grime from a plank of scrap wood, pulls a pencil from behind his ear, and begins sketching an idea born not from manuals, but from memory. Lines, angles, anchor points, a frame, a jig that could hold a broken wing exactly where it needs to be. Around him, engines sputter, crews shout, and the air war grinds on, unaware that this rough sketch might change everything that comes next. By the final months of 1944, the air war over Europe had become a relentless contest of endurance, and no aircraft symbolized that struggle more than the sleek, fast, long-range fighter known as the P-51 Mustang. Born from a rush order to support Britain's desperate need for modern fighters and refined after its pairing with the powerful Rolls-Royce Merlin engine, the Mustang had evolved into the Allied escort the strategic bombing campaign desperately required. Its range carried it beyond the Ruhr, beyond the Rhine, and deep into the industrial heart of Germany, places where earlier escorts simply couldn't survive long enough to protect the lumbering heavy bombers. Every mission flown by 8th Air Force and the hard-hitting fighter groups supporting it depended on a steady flow of operational aircraft, and by late 1944 the limiting factor wasn't production back in the factories. It was the brutal wear, battle damage, and mechanical stress piling up on forward airfield across France, Belgium, and the Netherlands. The air war had become a logistical race, and the quiet battleground was the muddy maintenance strips carved into farmland behind advancing Allied lines. There, under canvas roofs and flickering lamps, crews wrestled with twisted landing gear, flak-scarred wings, stressed fuselages, blown tires, burned plugs, frozen guns, leaking coolant lines, and all the countless wounds inflicted on high-performance fighters pushed to their limits day after day. The Mustang could slice through the sky at over 400 miles per hour, but could be humbled in an instant by a rough landing on pierced steel planking or a burst of 20 millimeters fire from a hidden German battery. Every time a damaged fighter rolled to a stop, the hours started to slip away, hours that could mean fewer escorts for the next day's bombers, fewer strafing runs for the infantry pushing through the Siegfried Line, fewer eyes in the sky over retreating German columns. What made the situation even more strained was the speed of the Allied advance. With each mile gained, maintenance units leapfrogged forward into newly secured ground, often operating from fields barely cleared of debris or hastily improved by engineers. These makeshift bases lacked the precision, tooling, and controlled environments that defined the great aircraft plants back in the United States. In places like Inglewood or Dallas, where Mustangs were assembled by the thousands, massive factory jigs held wings, spars, bulkheads, and control surfaces in perfect geometric alignment. Every rivet followed a predefined pattern. Every bolt was torqued to the exact specification. On the front line, none of that stability existed. A mechanic might be kneeling in mud, balancing a damaged wing root on a crate, or fighting freezing wind while trying to measure the deflection of a bent landing strut. Repairs that took hours in peacetime could stretch into days under combat conditions, and those delays rippled outward into the operational schedule. A single grounded Mustang didn't simply reduce a squadron's numbers. It weakened an entire mission's protective screen, leaving bombers more vulnerable and forcing commanders to recalculate their sortie strength. The pressure on maintenance crews grew with every passing week of the Allied push toward the German border. Adding to the strain was the constant rotation of units between escort, patrol, and ground attack missions. The Mustangs were flying more aggressively than ever, diving low to hit rail lines, convoys, and retreating armor, exposing their aircraft to a new wave of flak damage, tree-line impacts, and hard landings on improvised strips. Many fighters returned home bearing scars that tested the limits of field maintenance. Twisted gear mounts, warped lower wing skins, misaligned spars, and hairline fractures around stress points that could only be detected with careful inspection. Each type of damage demanded precision, not just strength, because a Mustang that was even slightly out of alignment could become unstable at high speed or uncontrollable under hard maneuvering. The margin for error was razor thin, and because squadrons operated on tight daily cycles, there was rarely enough time to perform these structural tasks with the meticulous, factory-grade accuracy they required. It was in this pressure cooker of urgency, exhaustion, and improvisation that countless small innovations quietly emerged from the hands of men who had once mended cars, tractors, and machinery in small towns across America. The war had taken their everyday problem-solving instincts and placed them into the crucible of global conflict, where even the simplest idea, a faster way to measure, a steadier way to brace, a cleaner way to align a structural member, could save hours, prevent rework, and get a Mustang back into the fight before sunrise. And it was precisely in this environment, surrounded by mud, noise, and the constant pulse of engines being coaxed back to life, that the stage was set for a small-town mechanic to look at one broken aircraft too many and decide that there had to be a better way, a way borrowed, not from manuals, but from the logic of the garage floor. Across the sprawling network of forward airfields supporting the Allied advance, the essential truth of the air war was becoming impossible to ignore. Victory in the sky depended as much on the men who turned wrenches as the men who gripped control sticks. These were the ground crews of the USAAF, aircraft mechanics, sheet metal workers, welders, armament specialists, electricians, hydraulics men, and crew chiefs, many of whom had never set foot in a machine shop before the war, and many others who had come straight from the small-town garages, farms, workshops, and trade schools of America. They arrived in Europe with skills forged in routine life, replacing fenders, straightening bent truck frames, welding cracked tractor arms, improvising tools when none were available. Now those instincts were being tested under canvas roofs, flapping in winter wind, with engines roaring overhead and bombardments shaking the ground beneath their boots. The Mustang, with its laminar flow wing and sleek form, was a masterpiece of engineering. Keeping it serviceable on a front-line strip turned that masterpiece into a daily test of endurance. In these forward zones, pre-flight checks happened in minutes, refuels in even less, and guns were reloaded with mechanical rhythm. But structural repairs, the unavoidable consequence of hard landings and combat damage, brought everything to a halt. When AP-51 taxied in with a groaning wing root or a splayed landing gear, the crew chief already knew what the next 48 hours would bring. Jacks sinking into soft ground, improvised wooden shims, tape measures stretched across cold metal, repeated remeasurements when fuselage lines refused to match the numbers printed in technical manuals. Structural repair instructions were precise, but the battlefield rarely was. Each twisted member had to be coaxed back into alignment through careful pressure and constant checking, because even a small deviation in the Mustang's geometry could compromise its performance at high speed. A fighter that dove cleanly before the repair might pull left afterward. A landing gear that locked firmly the day before might now vibrate or fail entirely under stress. And so the mechanics worked slowly, carefully, methodically, often at night, often soaked, often exhausted, knowing that rushing meant risking a pilot's life and wasting a machine that the war could not spare. What made these repairs painfully slow was the absence of one crucial resource that factories enjoyed in abundance: precision jigs. In North American aviation plants, massive steel frames held wings and fuselage sections in exact position while workers riveted and bolted components into place. These jigs removed guesswork. They made alignment a product of design rather than judgment. But on the front line, the closest thing to a jig was a stack of crate boards nailed into a shape that seemed about right, or a length of angle iron hammered straight against a bench. When a wing needed truing, mechanics had only their tools, their measurements, and their instincts Three elements that, under stress, fatigue, and bad weather, could never truly match factory precision. And as the tempo of operations increased, these misalignments accumulated. A slightly off-true wing could become a drag penalty. A barely corrected landing gear strut might fail on the next hard touchdown. Every hour of labor saved was precious, but every shortcut invited disaster. And this tension gnawed at crews who knew how little margin for error their aircraft possessed. Meanwhile, operational pressure was intensifying. Fighter groups were flying deeper escort missions, more ground attack sorties, more reconnaissance sweeps, all while operating from hastily captured fields where uneven surfaces and debris inflicted damage the enemy didn't even have to fire a shot to cause. The result was a backlog of grounded Mustangs waiting for structural attention, a queue that stretched longer than any mechanic wanted to admit. It was in this bottleneck that necessity pushed improvisation to the forefront. Mechanics looked for patterns in recurring damage. Landing gears tended to bend at predictable points. Wing skins tore along familiar lines. Spars warped in known directions. If damage was predictable, perhaps repair could be standardized. If alignment was always the problem, perhaps something could hold the aircraft steady. And if the front line lacked factory equipment, perhaps it could be recreated in miniature, scaled down, improvised, rough-edged but functional. This was the mindset simmering across countless maintenance tents as 1944 drew toward its final, brutal winter. Somewhere among these men stood the small-town mechanic whose story anchors this documentary. A man who watched Mustangs stack up in the repair queue and recognized a problem he had solved countless times before the war, back when a crooked frame or warped axle rolled into his shop and left only after being braced, squared, and trued against a homemade fixture. The battlefield was different, the stakes unimaginably higher, but the solution, at least in his mind, was the same. And it was this realization, born from ordinary experience and sharpened by wartime urgency, that was about to reshape the way his squadron repaired the most important fighter in the Allied arsenal. At the center of this story lies a single mechanic, but the angles that define his contribution stretch far beyond one man and one moment. Beginning first with the human reality of who he was before the war uprooted his life and sent him overseas. Like thousands of USAAF ground crewmen, he had not trained in engineering laboratories or aircraft factories. He came instead from the practical, grease-stained world of small-town America, a place where machinery was fixed not by replacing entire assemblies, but by understanding how metal behaved under strain, how frames twisted and how to coax them straight again, how to brace, square, and align with only simple tools and common sense. In that earlier life, when a farm truck rolled in with a bent axle or a delivery sedan arrived with a crooked front end, he built makeshift jigs out of lumber, angle iron, and clamps to hold things true while he worked. These were not precision-engineered tools. They were practical devices shaped by need and refined by repetition. And in the world of rural mechanics, they worked. When the war eventually placed him under the wing of a P-51 Mustang, those same instincts followed him. He did not see a wing root or gear strut as an abstract assembly, but as a structure that could be measured, squared, supported, and trued if only he had the right fixture to hold it steady. This was the first angle. Human experience translated directly into wartime necessity, a skill set born in modest garages now applied to one of the fastest fighters in the world. The second angle is the technical truth behind jigs themselves, a truth so simple that it was almost invisible outside of factories. A jig is nothing more than a rigid frame that holds components in a fixed position while work is done. But in practice, it transforms the entire repair process. Aircraft structures, especially those as refined as the Mustang's laminar flow wing, demand precise geometry. A slight deviation in dihedral, a few millimeters of twist, or an improperly aligned gear mount can alter airflow, stability, or load-bearing behavior at high speed. In a controlled facility, massive steel jigs lock wings into perfect shape before riveting teams assemble them. But on a forward airfield, mechanics had to recreate those perfect shapes manually, relying on chalk marks, rulers, plumb lines, and instinct. Every measurement introduced the possibility of error. And because each repair was unique, no two damaged Mustangs were restored exactly alike. The brilliance of the mechanic's improvised jig was that it replaced this fragile process with something fixed and repeatable. Instead of measuring 20 times and adjusting constantly, the jig forced the structure into its correct shape from the beginning. It aligned hard points, set angles, and supported weight exactly where it needed to be. With the jig in place, the job became less about interpretation and more about execution. Metal could be trimmed, drilled, or riveted with confidence, and the final result matched factory specifications far more closely than guesswork ever could. The third angle lies in the tactical consequences of faster, more reliable repairs, an area often overshadowed by the glamour of dogfights and the fame of aces, yet one that mattered profoundly to operations. In the daily rhythm of the air war, sortie rate was a weapon in itself. The more fighters a squadron could put into the sky each morning, the more bombers it could protect, the more convoys it could strafe, the more reconnaissance it could complete, the more enemy aircraft it could force into defensive spirals rather than offensive attacks. Every hour AP-51 spent grounded represented an opportunity lost, a gap in the protective screen, a missing element in a mission's firepower and flexibility. If structural repairs that once consumed 2 full days could instead be completed in half the time, the improvement was not merely mechanical but operational. A repaired fighter could rejoin its formation the next dawn, strengthening the line rather than weakening it. When multiplied across a squadron that routinely faced bent gear, twisted panels, and wing root damage, the time saved translated directly into additional aircraft available at the moment commanders needed them most. Faster repairs also meant fewer cascading delays. A backlog of grounded Mustangs could shrink rather than grow. In essence, a single jig, built from scrap material and an idea, revealed the tactical power of maintenance efficiency. It demonstrated that innovation on the ground could influence the air above, that a mechanic's problem-solving could shape missions just as surely as a pilot's skill. This connection between the hands that held wrenches and the pilots who controlled throttles forms a critical angle of the story. The battlefield depended as much on the speed of repairs as on the speed of the aircraft themselves, and in this delicate balance, the improvised jig became a quiet yet decisive force. Beyond the human, technical, and tactical dimensions, the story widens into a broader landscape of wartime logistics, leadership culture, and even the contrasting struggles of the enemy, each angle revealing why a simple jig could ripple outward through the larger machinery of the air war. The first of these is the logistical reality governing every forward squadron of the United States Army Air Forces. In theory, repairs were divided into neat categories. Frontline crews handled basic servicing and minor structural fixes, while deeper structural work was meant to be completed at higher echelon depots far from the noise and threat of the front. Yet theory rarely survived contact with operational pressure. Sending a damaged P-51 Mustang back to a rear area depot meant losing the aircraft for days or weeks, an unacceptable delay during the winter of 1944 as Allied air power strained to support ground forces closing in on the German border. Forward units therefore stretched their capabilities, taking on repairs that exceeded their intended scope simply because the alternative was watching scarce fighters sit idle during critical missions. This overextension wasn't due to negligence. It was the unavoidable consequence of war's relentless tempo. Every squadron lived in a constant tug-of-war between doctrine and necessity, and any tool that allowed them to perform near-depot-level structural work on the spot was an operational gift. The improvised jig, rough as it appeared, gave them exactly that, a way to turn battlefield conditions into something closer to factory precision, compressing the entire repair chain into a single muddy tent at the edge of a forward strip. The second angle emerges from the leadership ethos that defined effective maintenance units during the final push into Germany, an ethos shaped less by strict hierarchy and more by a shared commitment to keeping aircraft in the air. Commanders, crew chiefs, and inspectors understood that innovation often came from the bottom up. Wartime necessity had blurred the old boundaries between officer and enlisted insight. What mattered was whether something worked, not who proposed it. In this environment, the small-town mechanic's jig was not dismissed as unorthodox, but embraced as practical. Leaders recognized that mechanics were not simply following technical orders. They were interpreting them under duress, adapting them, finding ways to achieve the same structural outcomes with fewer tools, less time, and harsher conditions. This culture of trust allowed the jig to prove itself without bureaucratic delay. Crew chiefs watched the first repairs completed with startling efficiency. Maintenance officers noted the clean alignment and absence of post-repair issues. Inspectors found no deviation from structural standards. Instead of resistance, the mechanic encountered encouragement. Improve it, refine it, replicate it. Such openness was not accidental, but a defining feature of well-run wartime units. The war rewarded practicality, and practical solutions rose to the top. Leadership's willingness to adopt ideas from anyone who had them was a quiet but vital strength, one that enabled countless field innovations to flourish unseen by the public eye. The improvised jig was simply one more example of this wartime truth. Victory often hinged on the ability to recognize a good idea regardless of its origin. The final angle comes from looking across the battlefield to the situation facing the enemy. The Luftwaffe of late 1944 was a force strained to the breaking point. German industry reeled under continuous bombing. Fuel supplies dwindled, and maintenance infrastructure deteriorated in parallel with shrinking territorial control. The Luftwaffe's forward airfields lacked consistency, spare parts, and experienced ground crews. Depot-level capabilities were fractured by relocation, destruction, and logistical collapse. Aircraft like the Messerschmitt Bf 109 and Focke-Wulf FW-190 were formidable machines in the air, but on the ground they suffered from chronic shortages of everything: tools, trained mechanics, replacement components, even safe shelter from air attack. German units often had to cannibalize wrecked aircraft to keep others flying, and structural repairs that required precision tools or fixtures were increasingly beyond reach. As the Allies advanced, Luftwaffe aircraft were frequently abandoned, not because they were destroyed, but because they were damaged in ways German crews no longer had the means to repair. In this context, the difference between Allied and German maintenance capacity became a strategic divider. While the Luftwaffe struggled to return damaged fighters to the air, the USAAF used ingenuity and adaptability to keep its squadrons at high readiness. A single American squadron equipped with well-maintained Mustangs could generate far more operational sorties than a German unit struggling to repair its few surviving aircraft. This disparity was not only a testament to industrial production or supply lines, but to the small innovations, like an improvised jig on a muddy French airfield, that cumulatively sustained Allied air strength. The enemy's weakness cast the mechanic's achievement in sharper relief. What seemed like a simple wooden and steel frame was, in truth, part of a larger pattern of Allied resilience, where every hour saved and every aircraft restored multiplied the pressure on an adversary already crumbling under the weight of lost capability. And so all these angles, logistical necessity, adaptive leadership, and the enemy's decline converged on a single point: the moment when one mechanic's practical solution would be put to the test. The jig existed now, built from scrap and instinct, waiting beside a damaged Mustang whose twisted frame would either validate the idea or expose its flaws, and that moment of truth was about to define the turning point of the story. The moment of reckoning began on an evening when the light was fading, the wind cutting across the forward strip, and the maintenance tents buzzed with the low, exhausted murmur of men who had already worked since before dawn. A battered P-51 Mustang had just been towed on the hardstand. Its left landing gear collapsed inward from a rough touchdown. The wing root visibly stressed, the lower skin creased along a line that every experienced mechanic recognized as trouble. Normally, this kind of damage set off a familiar chain of events: block the aircraft, jack it carefully on uneven ground, remove panels, test the integrity of the spar, loosen mounting bolts, take half a dozen measurements from reference points that never seem to agree, then repeat the process until the structure finally settled back into something close to factory geometry. It was a job that demanded patience and accuracy, traits the crew had in abundance, but it also demanded time, something the squadron no longer possessed. The next morning's mission roster already hung outside operations, and every available fighter mattered. Yet as the crew gathered around the wounded aircraft, the small-town mechanic who had built the improvised jig stood slightly apart, steady and silent, watching the scene with a different kind of focus. He had spent the previous night refining the contraption he and a few helpers had cobbled together from scrap steel braces, lengths of angle iron, and wooden block salvage for packing crates. The jig looked rough, even crude, but it was engineered with purpose. Each contact point aligned with known hardpoints on the Mustang's wing and fuselage. Each brace measured to hold the structure at the correct dihedral and angle of incidence. Each block shaped to prevent twisting under load. The question now was whether this homemade frame could replace hours of measuring and remeasuring with a single, stable geometry. As the aircraft settled onto the jacks, crew chiefs exchanged glances, some skeptical, some curious, all aware that they had nothing to lose by trying. The mechanic stepped forward and asked for the jig to be brought over. It took 4 men to carry the frame into position, its weight a reminder that improvisation in wartime was rarely delicate. They slid it under the damaged wing, adjusted the supports, and locked the fuselage contact points into place. Immediately, the jig revealed its value. Instead of wrestling with shifting angles and sinking jack pads, the aircraft structure rested in a repeatable, factory-like orientation. The wing lifted smoothly into alignment, its sag corrected not by guesswork, but by predetermined geometry. The mechanic checked for square, sighted down the leading edge, measured a reference point against the manual, and nodded. Everything matched exactly as planned. What normally required 2 hours of cautious adjustment had taken minutes. Around him, the other mechanics leaned in, their skepticism softening as they realized how much effort the jig had removed from the process. They began removing the damaged skin, exposing the bent rib and stress bar cap beneath. Under normal conditions, correcting this would involve constant halts to confirm alignment, but now the structure held steady. The spar could be trued without worrying that the entire wing would shift the moment pressure was applied. The hours that followed were still laborious. Metal never yields easily, and a Mustang's wing root is no simple assembly. But the rhythm of the work had changed. Instead of stopping repeatedly to verify measurements, the crew moved with a confidence they had rarely experienced on the front line. They trimmed the torn skin, straightened the rib, reinforced the mounting point, drilled out damaged rivets, and pulled fresh ones with a precision normally reserved for depot shops far behind the lines. The jig absorbed the stress of every adjustment, holding the wing in the exact position required. The mechanic who had built it remained quietly attentive, stepping in only when needed, guiding the process with a steady understanding of how the structure should behave. By the time the sky turned completely dark and the lamps cast long shadows under the wing, the hardest part of the repair, the part that normally decided whether a fighter would fly tomorrow or next week, was already complete. The wing root sat square, the gear mount true, the spar cap properly aligned. Now the repair was no longer a battle of geometry, but simply a matter of closing up the skin and checking systems. Word spread through the maintenance area that something unusual was happening, and by the time the last rivet was set, even the duty officer had stopped by to observe. He knew how long these repairs usually took. He could hardly believe how far along the crew was. But no one celebrated. They all understood that nothing mattered until the aircraft was off the jacks and rolling under its own weight. Near midnight, the jacks were lowered, the Mustang settled onto its gear, and the alignment held perfectly. The tail did not dip, the wing did not twist, the gear stood straight. For the first time, the idea was no longer a theory scribbled on a plank or a rough frame assembled from debris. It was a functioning tool that had cut a major repair from days to hours. And as the crew stepped back, exchanging nods in the lamplight, one truth settled across the muddy strip. If this jig worked again tomorrow, and the next day, and the next, it could change the way this entire squadron kept its fighters flying. And that possibility, that a single idea might reshape a unit's combat readiness, carried the story directly into the moment when the jig would prove itself beyond any doubt. The real test came not on the night the jig was first used, but in the days that followed, when the squadron faced a surge of damaged aircraft returning from a series of intense escort and ground attack missions. The winter weather had turned the airfield into a patchwork of soft earth and frozen ridges, making every landing a gamble, and several Mustangs came back with bent gear doors, strained wing roots, and impact stress around the lower spars. Under ordinary circumstances, such a cluster of structural repairs would have overwhelmed the maintenance line, forcing hard decisions about which aircraft could be salvaged in time for the next day's operations and which would have to wait until the backlog eased. But now the improvised jig stood ready beside the tent, still streaked with mud from its first trial, its steel braces cold and rigid in the morning air. When the first damage fighter of the day was positioned over the jacks, the mechanic who created the jig wasted no time. He directed the crew with quiet confidence, knowing exactly where each support needed to sit, where each contact point aligned with the airframe's geometry. The moment the jig was locked into place, the wing rose into its correct angle as if guided by an invisible template. Measurements that once consumed precious minutes now confirmed alignment in seconds. The crew chief, who had repaired Mustangs since the earliest days of the group's arrival in Europe, shook his head in disbelief as the numbers matched the specifications almost perfectly on the first attempt, something he could scarcely remember happening under field conditions. By midday, the transformation was unmistakable. The second aircraft rolled into position, then the third, each one suffering familiar forms of stress from hard combat flying. What had once been a grueling process of trial and error alignment became a clean, predictable workflow. Mechanics moved with a speed that bordered on choreography, one man positioning the jig, another securing bolts, another checking alignment, another prepping damaged skin for removal. The jig removed the uncertainty that had always haunted repairs of this type. Instead of wondering whether a surface was truly straight or whether a mount had shifted under the weight of the jacks, the crew knew, with a certainty they rarely enjoyed, that the aircraft was being restored to the proper shape. Their focus could shift from fighting the geometry to executing the repair. Rivet lines straightened, spar caps sat flush, and control surfaces matched factory tolerances with almost uncanny consistency. The more they used the jig, the more they trusted it, and the more their work accelerated. What astonished them most was not simply the reduction in time, though cutting major structural repairs nearly in half changed everything, but the uniform quality that resulted. Post-repair inspections, usually tedious affairs marked by minor adjustments and corrective tweaks, now passed with minimal notes. The aircraft rolled out with clean signatures and confidence behind them. As the days continued, the effect multiplied. By the end of the week, the squadron recorded one of its highest availability rates since entering combat. Not because fewer aircraft were taking damage, but because more of them were returning to service after repairs that previously would have sidelined them for days. Pilots noticed the difference first in passing. A Mustang they assumed was out of action still parked in the flight line at dawn, warmed up and ready for takeoff. Crew chiefs began scheduling their teams with an efficiency they had never been able to attempt before, knowing the longest jobs were no longer unpredictable marathons, but manageable tasks anchored by the stability of the jig. Even the maintenance officers, who had grown accustomed to submitting reports explaining delays from structural workloads, found themselves writing shorter entries, noting the steady return of fighters without the usual list of complications. The transformation was so stark that the squadron's commanding officer requested a demonstration. He watched as the jig was fitted beneath a damaged wing, saw how the structure aligned under its fixed geometry, and understood immediately the broader significance of what he was witnessing. He did not issue a formal commendation. Wartime rarely left room for ceremony, but he did one better. He ordered the jig duplicated. Soon there were two, then three, Each one improved slightly from feedback gathered in long nights of muddy labor. The mechanic who had built the first jig did not treat them as inventions, but as evolving tools. He refined brace positions, thickened certain supports, added notches and guides to speed placement, adjusted block angles to match recurring damage patterns. By the time the squadron relocated to another forward field during the Allied advance, the jigs traveled with them like prized equipment, carefully strapped into transport trucks between tool chests and engine crates. And everywhere they went, their effect remained the same. Fewer fighters grounded, fewer delays, fewer doubts about whether a structurally stressed Mustang could be made airworthy before morning. The front line had gained a quiet form of insurance against operational fatigue, not from new aircraft arriving by the dozens, but from the ability to restore the ones they already had. What history would record from this period were sortie totals, victories claimed, missions flown, and advances supported. What it would not record, except in scattered notes buried in maintenance logs, was the sudden drop in repair hours, the shrinking backlog of damaged fighters, and the unexpected resilience of a squadron that rarely seemed short of aircraft. No official document would explain that a scrap-built jig, shaped in mud and necessity, had strengthened the squadron's combat power more reliably than any single replacement airframe. Yet the men who worked beside it every night understood the truth. They could see the difference in the aircraft returning to operations, in the pilots who trusted their machines without hesitation, and in the maintenance tents where exhaustion no longer carried the weight of futility. The jig had proven itself beyond question, and with each success, it became not merely a tool, but a symbol of how ingenuity on the ground could sustain superiority in the air. And as the squadron prepared for the next phase of the campaign, this newfound confidence, born from steel bars, wooden blocks, and one mechanic's refusal to accept wasted time, carried forward into the unfolding aftermath of the war. In the weeks that followed the jig's arrival on the maintenance line, the squadron statistics began to shift in ways that were subtle at first, then unmistakable. Aircraft availability, the quiet metric that determined how many fighters could actually launch when dawn broke, climbed steadily, even as missions grew more demanding and weather more unforgiving. Ground crews felt the difference before anyone else. They no longer faced the demoralizing sight of a row of grounded P-51 Mustangs waiting for structural attention that would consume days and drain the energy of an already overworked team. Instead, repairs that once pushed men to the brink became manageable tasks, predictable in duration, consistent in quality, and free from the frantic uncertainty that had defined field work for so long. Where once a bent landing gear mount might tie up an aircraft for 48 hours or more, now it returned to the line the next day. Where a twisted wing root once demanded repeated measurements, realignments, and corrections, now it behaved under the fixed geometry of the jig, allowing mechanics to focus on workmanship rather than wrestling with shifting airframe angles. The effect was cumulative. A fighter saved today strengthened tomorrow's mission. A squadron strengthened tomorrow multiplied the strength of the entire group. Each repaired Mustang represented not just a machine restored, but a pilot protected and a mission reinforced. What the officers noticed was the disappearance of bottlenecks. Maintenance briefings that previously involved discussions about shortages of serviceable aircraft now centered on planning, on efficiency, on how many Mustangs could be spared for deeper inspections precisely because the major structural work no longer consumed every available pair of hands. The squadron's commanding officer, reviewing daily readiness reports, saw the numbers stabilize at levels that earlier months had made seem impossible. What changed was not morale alone, nor discipline, nor supply. It was the ability to reclaim time, the most precious resource in wartime aviation. Time meant flexibility in mission assignments. Time meant fewer last-minute pilot reassignments to unfamiliar aircraft. Time meant the luxury of addressing small issues before they became major ones. And most importantly, time meant the squadron could maintain a higher sortie rate, providing more escorts to bomber formations, more coverage for ground forces, more pressure on retreating German units. The jig had no serial number, no paperwork, no official recognition, yet its influence reached into every mission flown from that muddy airfield. Pilots, too, felt the change, though many never understood its full origin. They noticed that damaged fighters returned quickly, often faster than expected. They noticed that post-repair test flights felt stable, precise, predictable. They noticed fewer quirks, fewer vibrations, fewer misalignments that sometimes crept into field repairs performed under extreme stress. For them, trust in the aircraft was more than convenience. It was life itself. A fighter with even a slight structural irregularity could betray its pilot at the worst moment imaginable. Knowing their Mustangs had been restored with a level of consistency that rivaled factory conditions gave pilots a confidence that rippled into their performance in combat. Confidence sharpened decisions, steadied hands on the stick, and reduced the mental burden that fatigue so often magnified. The small-town mechanic who built the jig never claimed credit, never sought recognition, and never asked for praise. He continued working quietly beside his fellow crewmen, guiding them when needed, refining the jigs when time allowed, and treating their success as the natural result of shared determination rather than personal ingenuity. But those who worked with him understood the truth. They were seeing, in real time, how a single idea could shift the balance of effort across an entire unit. They also understood something deeper, that the war's outcome depended not only on the famous machines or the celebrated pilots, but on the countless, unrecorded innovations that allowed aircraft to keep flying day after day. The jig was one such innovation, born of necessity, shaped by experience, and validated through hard labor. And as the squadron pushed closer to the German border, with missions increasing in intensity and the demands on every Mustang growing heavier, the quiet victory achieved on the maintenance line prepared them for a second wave of consequences that would follow them into the closing months of the war and long after the fighting had ended. As the war pressed into its final, punishing months, the lessons born from that improvised jig echoed far beyond the muddy strip where it was created. The ability to restore damaged fighters quickly and accurately had given the squadron a resilience that commanders came to rely on, but its influence stretched deeper into the very fabric of wartime maintenance doctrine. The USAAF had always emphasized organization and procedure, yet no manual could fully anticipate the relentless conditions of operating at the edge of advancing lines, where cold winds carried the smell of spent fuel, where snow drifted against the canvas of maintenance tents, and where the tempo of operations left no margin for error. In this environment, field innovations, some tiny, some transformative, filled the gap between doctrine and reality. The jig became a quiet emblem of this adaptability. Crews refined it, strengthened it, and passed their notes along as they moved from airfield to airfield, carrying with them not just a tool, but a mindset that equipment, processes, and even long-established rules could be reshaped to meet the demands of the moment without compromising safety or structural integrity. In many ways, the jig was a small preview of the larger shift that would sweep through post-war aviation as militaries and civilian industries alike embraced the idea that efficient, standardized repair tooling was not a luxury, but a necessity. When the guns finally fell silent in Europe, thousands of mechanics and technicians returned home, carrying with them experiences that no classroom could have taught. Some went on to work in commercial aviation, where the rapid expansion of airlines required new approaches to maintenance, inspection, and structural repair. Others joined manufacturing plants or engineering shops, bringing with them the wartime habit of solving problems by building what did not yet exist. The principles they had practiced on the front lines, precision under pressure, standardization of critical tasks, and the use of jigs and fixtures to eliminate inconsistency, helped shape the post-war rise of American industry. Even in the world of small-town garages, the influence lingered. Mechanics who once improvised alone now thought in terms of efficiency, repeatability, and alignment standards shaped by aircraft rather than automobiles. The war had elevated their craft, turning practical intuition into structured technique, and many carried those refinements into civilian life without fully realizing how profoundly the experience had changed them. The legacy extended into the military as well. The importance of rapid, reliable structural repair had been proven in thousands of overlapping moments across the European theater, and as new aircraft designs emerged, faster, heavier, more demanding, the lessons learned from the P-51 carried forward. Specialized repair jigs became central to peacetime doctrine, replicated in depots and field units alike, ensuring that the principles discovered under duress became formalized in training and procedure. What had been improvised out of necessity in wartime, mud became standardized equipment in post-war hangars. And while the small-town mechanic's name may never have appeared in technical reports, his contribution lived on in the quiet, enduring truth that good ideas, once proven in combat, rarely remain isolated. Yet perhaps the most lasting consequence was philosophical rather than mechanical. The jig's success illustrated something that history often overlooks. Wars are not won solely by the brilliance of commanders or the heroism of pilots, but by the persistence, creativity, and problem-solving of those who labor unseen. It showed that innovation is not the exclusive domain of laboratories or headquarters. It can emerge from a man staring at a broken machine in fading daylight, determined to find a faster, better way to make it whole again. And in the years after the war, as the world rebuilt itself and aviation entered a new era, that quiet philosophy shaped the backbone of modern maintenance culture. The belief that the simplest improvement can have the greatest impact, that tools made with one's own hands can change outcomes, and that the integrity of an aircraft or any machine rests on the ingenuity of the people who care for it. It was this understanding, carried forward in memory and practice, that brought the story of the improvised jig full circle, a field-born idea that outlived the war itself, reminding all who encountered its legacy that even the smallest creation, built from scrap and necessity, could influence the path of history. In the quiet after the war, when the temporary airfields were long abandoned and the roar of the P-51 Mustang had faded into memory, the true weight of what happened on those muddy strips became clearer. The Mustang is remembered today for its elegant lines, its speed, its long-range escort missions, and the pilots who carried it into danger. But the aircraft's legacy was also shaped by the hands that kept it alive. That improvised jig, born from scrap wood, salvaged steel, and one mechanic's refusal to accept wasted time, symbolized a truth that rarely reaches history books. Progress often begins in the shadows, in the spaces where necessity pushes ordinary people to create extraordinary solutions. The war was filled with such moments, thousands of them, scattered across maintenance tents, engine sheds, machine shops, and supply depots. They were not dramatic in the traditional sense. No medals were pinned for them. No citations were drafted, yet they changed the war in ways as measurable as victories on the battlefield. Every time a pilot walked to a fighter he thought would be grounded for days, every time a Mustang rose cleanly into the gray dawn after a long night of repairs, every time a mission launched at full strength instead of reduced numbers, a small part of that success belonged to the unseen ingenuity of those who worked through cold nights and unforgiving schedules. The jig was just one example, a simple frame that restored geometry, saved hours, and gave a squadron the momentum it needed. But its significance was larger than the tool itself. It demonstrated that war is not only shaped by strategy and firepower, but by resilience, adaptation, and the refusal to let obstacles dictate outcomes. And long after the last Mustang left frontline service, the spirit behind that jig lived on in the workshops, factories, and airfields of a world rebuilt by veterans who carried home the belief that with enough determination, anything broken can be made whole again.